Now that we have seen the basic graphs of sine and cosine, we can perform transformations on them. So this will be a little bit of an algebra review at the beginning of, I'll do a bit of an algebra review at the beginning of the video and also introduce the trig aspect of it, and then we'll do 2 examples. So you have that, right, your basic function, which is y is equal to sine of x, and y is equal to cosine of x. And then what you're going to do is be putting numbers into the formula. So as you can see, we have an a, and the same thing on the other one, an a. And then we have a b, and here, same thing, the b. And then we have a c. And depending on where these numbers are, so depending if it's on a, b, or c, where they're placed in the equation is going to give you a different type of transformation. So when you're doing your basic graph, so your basic graph is either going to be sine or cosine, very easy to see, whichever one is in the equation. You're going to have key points that you're going to transform, and both of them are going to have 5, and they're going to be really easy to know which one they are because they're the axis angles. So it's going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And it's the same, going to be the same thing for cosine, 0, pi over 2, pi, 3 pi over 2, and 2 pi. But of course, as we know, they're going to have a different output because sine is the y-coordinate on the unit circle and cosine is the x. So let's write our axis points, which we use a lot. So hopefully we're getting cozy with them. So first I'll look at sine. So sine is going to be the x-coordinate. Oh, I'm sorry, the y-coordinate. Highlighted the y and said the x. It's going to be the y. So the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is -1. And the sine of 2 pi is 0. And then we're going to look at cosine, which I'll highlight in orange. Now this is the x-coordinate. So the sine of 0 is 1. The cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is -1. The cosine of 3 pi over 2 is 0. And the cosine of 2 pi, we're back to the beginning, is 1. So here are your key points. And we saw these graphed. We saw what kind of graph it gives you when you plot these. So it's that nice curved roller coaster looking graph. And now we're going to perform transformations on these. So we're going to introduce 3 kind of words. The first one is called the amplitude. The amplitude is going to change your range. So your range is currently -1 to 1, and the amplitude can increase the range or decrease the range, and that depends on the letter A. So your amplitude will always be the absolute value of that number in the front. So A is the number that's in front of the equation. If A is not there, it's assumed to be 1, and the amplitude is going to be 1, and the range stays -1 to 1. So if you don't have a number in the front, it does not change the range. Your period of your graph is denoted by the letter T. So the original period of sine and cosine is 2 pi. And then the formula for the period is going to be 2 pi divided by b. And if you look at the equation at the top, b was the orange. It's the number in front of x. So if there's a number in front of x, the period will change. If there's not, it's assumed to be 1 and the period stays 2 pi. And then you have a phase shift. Phase shift is the way that we call a horizontal shift in trigonometry. And the phase shift, which I'll call PS, the formula for that is -c over b. So if you take a look up here, c is the number that is inside the parentheses of cosine and sine, but it's being added or subtracted to the x. So if c is positive, in the formula you grab the negative version. And if c is negative, in the formula you grab the positive. So you grab the opposite sign. So that's what the negative in the front does. And then you divide it by b. So again, we're going to see all of this in a few examples. Now let's talk a little bit about an algebra review. So you're going to have your key points, your 5 key points. And I'll label these x, comma, y. So the first thing you're going to do is you're going to apply the a. So I'm going to use sine here just to have what the equation looked like with us. So the first thing you're going to do is, and let me stick to the same color, so green first. Okay, first you're going to take care of the a. what you're going to do is you're going to take the y's that are in your points and you're going to multiply them by a. When you do this to the graph, it's going to be a vertical stretch or shrink. It can't be both. It can either stretch or shrink, and or a reflection. Now, a reflection can be by itself, or it can be with a stretch or a shrink. How do you know what you're going to have? Well, you're going to have a stretch if the absolute value of a is greater than 1. You're going to have a shrink if the absolute value of a is less than 1. And you're going to have a reflection if a is negative. A vertical reflection, and a vertical reflection is an x-axis reflection. So that's only going to change your y's. That's on the outside of the equation, so that's why it affects your y's. Those are vertical transformation. Again, a little bit of a review there. Next, you're going to take care of your b that's in front of x. So what you're going to do, and this is the part that maybe some of you remember from algebra that is tricky, is that horizontal transformations, you live in opposite world. So unfortunately, you don't multiply your x's by b. You multiply it by the reciprocal of b. So I'll write reciprocal. So if b is 3, you multiply it by 1/3. If b is 1/5, you multiply it by 5. So you take the reciprocal of b. What that's going to create is the same as above, but instead it's going to be horizontal. So it's going to be a horizontal stretch, shrink, and or a reflection. And because you live in opposite world, what I wrote above about A is the opposite for B. So it's a stretch if B is less than 1, because when you take the reciprocal, it will actually be greater than 1. It's a shrink if B is greater than 1. And the only part that doesn't change is the reflection. If it's negative, it's a reflection. But this time it will be a horizontal reflection, which is a y-axis reflection. And last but not least, you're going to take care of the C, which actually really goes with B. So it goes with your phase shift. So the last thing you're going to do is apply your phase shift. So you are going to first find your phase shift, and then at the end, you're going to apply it. So you're going to take your x's, and whatever you got for your phase shift, that negative C over B, you subtract or add it to x. So if it's negative, it's your phase shift, you're going to subtract. If it's positive, you're going to add. Whatever the sign is what you apply to your x's. And so this is going to be a horizontal shift. And a horizontal shift means that you either go left or right. And so what's important here is that you go in order. Okay, so you're going to have your key points, your original points. Then you're going to apply the A to the Y. Then you're going to apply 1 over B. And then you're going to do the horizontal shift. So it goes in steps. They all follow each other. So whatever you found in the first step, that's what you use in the second step. Whatever you found in the second step, that's what you use in the third step. Okay, enough. Let's do an example. Okay, my function is f of x is equal to 3 cosine of 2x minus pi over 2. So just to put it out there, just to see, a is 3, b is a number in front of x, which is 2, and c is a negative pi over 2. So my amplitude is the absolute value of a, which is the absolute value of 3, which is just 3. The period is going to be t is equal to 2 pi over b, which is 2 pi over 2, which reduces to pi. That means that my graph is going to have a cycle of pi. So it's going to repeat itself pi units now, not 2 pi. So it repeats itself faster. The phase shift, PS, is negative c over b. So because c is negative, and the negative is going to make it a positive. So it's going to be a positive pi over 2 over 2. Be very careful with your algebra here. This is 2 over 1. So when I flip it, it's 1 over 2. That's probably one of the most common mistakes I see here. People bring it up and say pi over 2 times 2. You have to take the reciprocal when you bring it to the top. So this is pi over 4. It's a positive pi over 4, so it will shift to the right. My basic function, very easy to see. I can see right away it's cosine. My key points, okay, well, I know it's the axis angles. And then I just evaluate cosine. So, and again, if you need to, you draw your little thing here, right? Very helpful. Cosine of 0 is 1, then 0, then negative 1, then 0, then 1. Okay, so now we're going to start transforming. So the first thing you're going to do is take A. What you need to be careful of is that you take A, you don't take the amplitude. So if A is negative, you have to take the negative, because remember, that's a reflection, and the reflection has to come with you. So my final key points are going to be, first, I'm going to apply the 3 to the y. Then I'm going to apply the reciprocal of b. So because b is 2, I'm going to multiply the x's by 1/2. And last but not least, I'm going to apply my phase shift. My phase shift is a positive pi over 4, so I add pi over 4. So here it is, and here it is, right? It's the same, whatever you get for the phase shift. Okay, so let's apply the 3y first. So my x's are not going to change. So they're just going to be the exact same axis angles from above. But then I'm going to apply here. So these are the y's, and I'm going to multiply them by 3. So 1 times 3 is 3. Anything times 0 is 0. Then I get -3. This stays 0, and this changes to 3. Because I'm multiplying by a number greater than 1, this is a vertical stretch. So it's going to make the graph bigger up and down. There's no negative, so there's no reflection. Okay, next what I'm going to do is I'm going to multiply by 1/2. So now the y's stay the same. So I'm not changing my y's, but what I am changing are my x's. So my x's from the previous step. Actually, let me do green. So I'm going to multiply by 1/2 these x's, right? Because I'm going in a row. I'm going steps to step. So 1/2 times 0 is 0. Then this is going to be pi over 4. This is going to be pi over 2. This is going to be 3 pi over 4. And this is going to be pi. So because the number is, I'm making the numbers smaller, this is a horizontal shrink. So it's going to squish it like a machine is going to compress it on the left and the right, which is why the period becomes smaller. And last but not least, I'm going to add pi over 4 to the x's. So again, the y's don't change. And then what I do here is that I take the x's from the previous step and I add pi over 4 to them. So 0 plus pi over 4 is pi over 4. Pi over 4 plus pi over 4. And if you need to do your fractions on the side, take your time. This is 2 pi over 4, which reduces to pi over 2. Then I have pi over 2 plus pi over 4. I need a common denominator. So this is 2 pi over 4 plus pi over 4, which is 3 pi over 4. Then I have 3 pi over 4 plus pi over 4. That's 4 pi over 4, which is pi. And then I have pi plus pi over 4. I need a common denominator, 4 pi over 4 plus pi over 4, which is 5 pi over 4. And here are your final key points. I have applied all my transformation. My last one was a horizontal shift, a phase shift. And more specifically, because I added, it was a phase shift to the right. So, final step is to graph one cycle of the basic. Okay, so I'm going to graph the basic function, which was cosine. In part E, I have my basic points. So it's 0, 1, pi over 2, 0, then -1, then 0, then 1. And I'm going to do it dashed. And I just asked for one cycle, okay? So you don't have to do the entire thing. You can if you want, but I'm not asking for that, just one cycle. And then the final equation, you're going to graph one cycle, and then you're going to complete the graph. So we're going to have pi over 4, 3. Now, pi over 4 is 45 degrees. It's right in the middle of 0 and pi over 2. So here we have the point. Then we have pi over 2, 0. Oh, so it's going to be the same point here. I should have done a different color, but it's okay. I have 3 pi over 4. 3 pi over 4 is right in the middle of pi over 2 and pi, and that's -3. Then I have pi 0, so here it is. And then I have 5 pi over 4, 3. And 5 pi over 4 is right in the middle of pi and 3 pi over 2. So when I connect my points, Here is my one cycle. So visually, you can see the transformations. So if you look at the dashed compared to the solid, it's been vertically stretched. So somebody has taken the graph on the top and the bottom and stretched it vertically. Then it's been horizontally compressed, horizontally shrunk. So somebody has taken the graph left and right and pushed it together. And then it's been shifted a little bit to the right. So here are your three transformations. Now you have to finish the graph. So the pattern of the graph is 3, 0, negative 3, 0, 3. And it's happening at, the changes are happening at pi over 4. So this one, I'll finish the graph in a different color. So I'm at top at 3, so I got to go back down to 0, and then negative 3, and then 0. So here's the next cycle. And then in the opposite direction, I got to do the pattern backwards. So 0, 3, negative 3, 0, positive 3, 0, negative 3, 0, 3, 0. And then I connect. Remember, it's not lines, right? It's a nice, think of like a roller coaster. And here it is. So my entire thing is everything that's solid is my graph. And of course, the domain is still all real numbers, so it continues still on either side. And then I can compare it to how it was to my basic. Let's do one more. Okay, that's right. So A is negative 2, B is 1/2, C is a positive pi over 4. My amplitude is the absolute value of negative 2, so it's 2. So it's going to change my range. It's going to make it bigger. My period is 2 pi over b. This is 2 pi over 1/2, which is equal to 2 pi times 2 over 1, which is equal to 4 pi. So now it's going to be bigger, my graph. The cycle is going to repeat in larger amounts. The phase shift is going to be negative c over b. So c is a positive pi over 4, so it becomes a negative pi over 4. B is 1/2. Again, be careful with your algebra here. This becomes 2 over 1, which is a negative pi over 2. So it's going to go to the left now. My basic function, very easy to see, it's sine. It says it directly in the equation. My key points, okay. I know it's the axis angles. And then if you need to, you can draw your little diagram with the points. So sine will be the y's. So it's 0, then 1, then 0, then negative 1, then 0. So now I'm going to do my final key points. So first I'm going to apply A. So it's going to be a negative 2y. Then I'm going to apply B. So B is 1/2. So I need to take the reciprocal of 1 over 2, which is 2 over 1. So I'm going to multiply my x's by 2. And then I'm going to apply my phase shift, and my phase shift was a negative pi over 2. Negative pi over 2, negative pi over 2. So whatever you get for part C is what you apply at the end. Okay, so my x's don't change. My axis angles are the same. Now, I'm actually going to teach you a little bit of a trick here, and if you want to use it, you can use it. These two can be done together, because one is affecting the y's and the other one is affecting the x's. So if you want, and if you feel comfortable, you can do it at the same time. If not, you can do it in 2 separate steps. So just to show, I'm going to do it. So first I'm going to do the x's. So 0 times 2 is 2. Then pi over 2 times pi over 2 times 2 is pi. Then 2 pi. Oops. I'm sorry, 0. 0 times 2 is 0. Pi over 2 times 2 is pi. Pi times 2 is 2 pi. 3 pi over 2 times 2 is 3 pi. And 2 pi times 2 is 4 pi. Then I'm going to multiply the y's by negative 2. So negative 2 times 0 is 0. Let's not make the same mistake. 1 times negative 2 is negative 2. 0 times negative 2 is 0. Negative 1 times negative 2 becomes a positive 2. And 0 times negative 2 is 0. So what I have done here is I have a vertical stretch and a reflection because it's a negative 2. So I'm making it bigger but reflecting it. And I'm also making my x's bigger, so I have a horizontal stretch. Right? So You might think the opposite because in the equation you see a 1/2 with the x, so you're like, oh, it's going to be smaller. But remember, you're taking the reciprocal because you live in opposite world. So it's actually going to make it bigger. And then we're going to apply the phase shift to these x's now. So 0 minus pi over 2 is negative pi over 2. Pi minus pi over 2 is pi over 2. 2 pi minus pi over 2 is 3 pi over 2. Then 5 pi over 2, and 7 pi over 2. If you need to do it, the fractions on the side, take your time, right? These are the really important points. The y's don't change here. I'm only doing something to the x's, and this is a phase shift to the left. Okay, here are my key points. So the instructions are the same. Graph one cycle with basic. I'm gonna do it in a different color this time. So the basic function of sine is 0, 0, then 1, then 0, then negative 1, then 0. I'm going to do it dashed. And then I'm going to plot my key points. So I have negative pi over 2, 0, pi over 2, negative 2, 3 pi over 2, 0, 5 pi over 2, 2, and then 7 pi over 2, 0. And here's my nice roller coaster. So the pattern is 0, negative 2, 0, 2, 0. So here I really don't have the space to go to the next point because I need to skip 2. So they're all a distance of pi away from each other. So when I have room to go backwards though. So if you take a look, every point here is a distance this much. It takes 2 little squares to go to the next point. So I'm at 0, I got to go up to 2, because remember, I'm doing my patterns backward now. I'm doing my patterns right to left. So I'm going to go up to 2, and then I'm going to go to 0, and then I'm going to go to negative 2, and then I'm not going to have space. So I'm going to go like this. Ooh, that was a little aggressive. Let's try that again. There we go. And then I could just pretend I know it's going to go over there. So here again, we can see our transformations. Look at the orange versus the black. So it's been vertically stretched and it's been vertically reflected, which is why the point was above and now the point is below. And it's been horizontally stretched. The graph is much bigger and it's been shifted a little bit to the left. And here it is.